Okay, so we're going to do lowest common multiple and greatest common factor. So, lowest common multiple means you're multiplying up, and greatest common factor means you're saying what gets divided into that number. So, we'll kind of learn these together. So if you said what's the least common multiple of 12 and 15, you're basically going to count up by 12. So you're going to say 12, 24, 36, 48. And if you don't know, then you would just have to do 48 plus 12 like this. And you would just do probably like 4 or 5. And then see if that's enough to get you a common number. And then again, 15, 30, 45. And you're just going to keep going. If you can't see what's next, it's 60, but suppose you can't see that, then you're just going to do the addition like this. And then we have our greatest common multiple. That's the number that they both have in common, and it's the lowest one. So you always pick the one that they share, but the lowest one. So then it would be 60. Greatest common factor is when, if you have 12 and 15 again, you're going to say what divides into 12 and what divides into 15. So you're going to list all the things that can be divided by 12. So 1 can be divided. Can 2 be divided? Yes. 12 divided by 2 is 6. So I'm just going to put 6 in there as well because we know if it can be divided, it's a factor. What about 3? Yes. 3 times 4. 4 is, what about 5? Is 5 a factor? No. 6, yes. 7, no, because 7 plus 7 is 14. 8, no. 9, 10, 11, no. No, no. Okay, so you do the same thing here. Does 1 go into it? Yes. Does 2 go into it? No, because 2 times something does not equal 15. Does 3 go into it? Yes. 3 times 5 equals 15. So I'm just going to put the 5 there as well. Does 4 go into it? No. Does 5 go into it? Yes. Does 6 go into it? No. Does 7 go into it? No. Once you get to the halfway point, 7 is half of 15, or 8, you don't have to go anymore, and you just close it off with the number. So now we look. Now we're looking for the greatest common factor. So 1 is a common factor, but it's not the greatest common factor. We have a 3 here. That might be the greatest. Let's make sure. No, no. Yep, 3 is the greatest common factor. Okay. Maybe not now, but soon you're going to do something called a prime factorization tree. And what that's dealing with are prime numbers. Have you learned about that yet, Cade?
No.
Okay. So prime number and a composite number. These are the two types of numbers that we have. So if you have a number that only can have factors, which are these, right? We divide, it's numbers that go into it. And the factors are only 1 and itself, then it's a prime number. So an example of that is the number 2. What numbers divide into 2? 1 and 2. So if it only has 2 factors, it's a prime number. So is 2 a prime number? Yes, because it only has 1 and itself. What about 3? Is 3 a prime number? Yes, because you can only do 1 and 3. So that's a prime number. What about 4? What are the numbers that can be divided into 4? We have 1. What about 2? Yes. What about 3? No. What about 4? Yes. So this one has 3 factors, so it's not a prime number. It's called a composite number. So this one only has 2 factors. This one has more than 2 factors. Okay, how about 5? No bark. No, no. What about 5? What factors get divided into 5? Well, does 1 go into it? Yes. Does 2 go into it? No. Does 3 go into it? No. Does 4 go into it? No. Does 5 go into it? Yes. So it only has 1 and 5. And that makes it a prime number. What about 6? 6 has 1. What about 2? Yes. What about 3? Yes. 4? No. 5? No. 6? Yes. So this is a composite number. So the first step to find out whether something's prime or composite is to list its factors. And factors means that the number can be divided into it. If there's only 1 and itself, then the number is called a prime number. If there's more than 2 numbers, then it is called a composite number. Does that make sense to you, Cade? Awesome. Okay, so the next concept is called a prime factorization tree. So we're going to have a number like 16, and they're going to say do a prime factorization tree of 16. You're going to pick 2 numbers that can be divided by 16. So suppose we picked 2. 2 times something equals 16. What is the something, Kate? Two times what equals 16?
8.
Yeah. So we're going to make a line here and a line here. And you're going to write 2 and 8. Now, is 2 a prime number? Yes, because the only 2 numbers that go into it are 1 and 2. So if it's a prime number, we circle it and then it ends. You don't have to do anything more with this number. Is 8 a prime number? No, because we have the factors of 1, 2, 4, and 8 that can be divided into 8. So we're going to pick 2 of those factors, and we're never going to pick 1 because then it's just going to keep turning into an 8, a 1 and an 8, a 1 and an 8. Does that make sense to you? If we picked 1 and an 8, the 8's never going to get smaller. So we're going to pick a different set of factors. We're going to pick 2 and 4. Well, we know 2 is a prime number, so I'm going to circle that. Is 4 a prime number? No. And how do I know that? Because our factors of 4 are 1, 2, and 4. So I have to keep factoring it out. What are 2 numbers that when multiplied together equal 4? 2 and 2. We know these are prime numbers, so we have a 2 and a 2 and a 2 and a 2. Now, this means multiplication, so there are a few ways now to show multiplication. One of them is to do 2 times 2 times 2 times 2. And another way is to do these dots like this. They're not decimals because they're up in the air, and a decimal is down like this. So it doesn't look like that. It's up in the air halfway between the top of the number and the bottom of the number. And this means multiply. So if we multiplied this out, 2 times 2 times 2 times 2, what would we get? So 2 times 2 is 4, times 2 is 8, and 8 times 2 is 16. So we just check it to make sure that this is the number that we started with. Is it the same? If it's the same, you did it right. If it's not the same, then you made a mistake. Does that make sense to you, Cade?
Mm-hmm.
Okay, so we're going to try the least common multiple of 6 and 24. So you're going to do that, and you're going to tell me what you got for your least common multiple.
Wait, so we're doing the thing that we just did?
The least common multiple.
I don't get that.
Multiple means multiply up.
So you have to multiply it down to get the least one?
No, you have to multiply up by 6. So you're going to count up 6, 12, 18 until you get to a common number for both of them. Do you want me to show you the example?
Oh, wait, so I count like 6, 12 by 6, and then the 24 by 24?
Yep. And this is what yours is going to look like. So you're going to, instead of writing a 12 and a 15, you're going to write 6 here and 24 here. And you're going to count up by 6s until you get a common number. And then you're going to count up by 24s until you get a common number.
And then left to they have to be the same?
Yeah, the same number, the smallest number that 6 and 24 have in common when you're counting up by that number.
Can it be 24?
It can be 24, whatever the lowest number is.
Okay, I got it.
Awesome. So, what did you do for 6?
24.
So, how did you do it? 6?
12, 18, 24.
Mm-hmm. And then what did
24
you... Yep.
is 24.
Exactly. And then we just circle them like this, and it's 24. All right, now we're going to do the greatest common factor of 6 and 24. So this is where we find out what's the common number that can divide into both of these numbers.
So the highest one?
The greatest common factor, yep.
52.
Okay, so here's what we're going to do. We're counting down. We're saying, can 1 be divided? Can 2 be divided? Yes. Can 3 be divided? Yes. Can 4 be divided? No. 5? No.
Can 1 be divided into 24?
Always 1, because 24 divided by 1 is 24.
Divided into 24.
Yeah, and then what about 2? Can 2 go into 24? Yes. 24 divided by 2 is 12. What about 3? Yes. 3 times 8 is 24. What about 4? Yes. 4 times 6 is 24. This is why we need to know our multiplication facts like a boss, because then it's going to make it easy. What about... What, honey?
I thought we were going from 6, 12, 18.
No. So factor. Factor means divide. You're dividing out. Multiple means multiply. That's how you can remember it. Okay, so let me finish this. 5 can't go into it. How about 6? Yes. And I don't have to go any further because I already have my 6 can't have a bigger number get divided into it. So the greatest common factor is, why do I keep making my 6s like that today? Is 6. Does that make sense? All right, now for our prime factorization tree, I'm going to have you do the number 20. So try that and then tell me if you get stuck.
The thing that you did 20.
Yeah, like this thing.
That and then yeah. Okay. And then they at the bottom they all have to make up to 20.
Exactly.
So they have to be 2s?
No, it can be any 2 numbers. You're just going to keep going down and down and down.
And it can't be 1.
Can't be 1. So I'm just going to do, these are 2 options. You can keep going. I'm recording this for Lila as well. So I want to make sure that it doesn't matter. It doesn't matter what you do. You can do any factors. It's totally fine. So these are the 2 options. You could have done this one or you could have done this one because you only have to pick 2 factors.
Wait, so I circle the 2 and then I put the 2 lines under the 2.
No. Once you get to 2, you're done. You circle it and then you're done because 2 can't go any lower because it's a prime number. Once you got it down to a prime number, you circle it.
And then you put the triangle under the other number.
Yep. And you keep going as small as you can go. All right, did you get that, honey?
Because I did 20, then I did 2 and 10.
Yep, and then you're going to say, what are the factors of 2 and 10, 2 and 5, and then you circle those, and then you're done. So now, if you chose to do this one, I don't know which one Lila chose to do, you're going to do 2 times 2 times 5. So all the numbers that are circled, and you go from least to greatest. So 2 is the least, and then we have another 2, and then we have a 5. If you did this one, it's going to come out to be the same number. That's why you can choose any 2 factors, because you're going to get the same answer no matter what, because you're just going to keep going lower and lower and lower. Does that make sense to you?
Yeah.
Okay, so that is prime factorization, and you'll know to circle it when it only has itself and another number. Okay, now we're going to go on to writing, and this is a good time to go over parts of speech. So we're going to go over what a noun is. A noun is a person, place, or thing. A pronoun is... My poor dog. There's a dog out there going crazy and making him go crazy. Are you barking a lot, buddy? Okay, a pronoun is a word that we replace a noun with. So if I said, Cade is here, I'm not going to say Cade every single time. So sometimes I might say, he is doing math. If it was Lila, I wouldn't say Lila every single time. I would say she. I could also say him, and I could say her, and together they make a thee, a they, a thee. And then all of us, so Cade and Lila and Anne are we or us, so that's what a pronoun is. They, them, us, we, he, she, I. And then there's another kind of noun called a proper noun. A proper noun needs to be capitalized, and it needs to be capitalized because it is an important or a specific name. So, Cade is a proper noun. Lila is a proper noun. Anne is a proper noun. Legos is a proper noun. If you go to Target to get your Legos, Target is a proper noun because it's the name of a specific store. Burton Park is a proper noun. Britton Acres is a proper noun. Arroyo School is a proper noun. Cedar Street is a proper noun. San Carlos is a proper noun. California is a proper noun. January, Monday, Christmas. Does that make sense?
Mm-hmm.
So if it is a noun that needs to be capitalized, it is called a proper noun. A verb is an action word. So it tells what the subject is doing. So Lila went on vacation. What did Lila do? She went. Cade is doing class with Anne. What is Cade doing? He is doing. My dog barked at the other dog. What did my dog do? My dog barked. Okay. Does that make sense to you?
Yeah.
All right. The next thing is called an adjective. An adjective is a word that describes something about the noun. So, go. So, Anne is annoyed at her dog. So, annoyed. Why is that an adjective? Because it's saying what the subject is. Here's Anne, and what is she? She's annoyed at Bear. Cade is what's something about a tall boy. Tall describes what kind of boy you are. Does that make sense?
Mm-hmm.
What about Lila has blonde hair? What kind of hair does she have? Here's my noun, and it's showing what kind of hair or how big something is. So an adjective will tell something about the rabbit. What kind of rabbit is it? It is a brown rabbit. What kind of puppy is it? It's a new puppy. What kind of cat is it? It is a fluffy cat. Does that make sense, or do you need more examples?
That makes sense.
Okay. We have something that is called an adjective. And an adjective is also a descriptive word, but it describes a verb. Sorry, adverb. So, I ran. How did I run? I quickly ran. I walked. How did I walk? Slowly. Okay, so what are some other examples? I gently patted my friend. I softly spoke. Does that make sense?
Mm-hmm.
Okay. So, an adverb can tell descriptions like when, how often, how much, and where. So, I fully understood. This tells a quantity of how much I understood. I somewhat understood the lesson. I never understand the lesson. Make sense?
Mm-hmm.
Okay. I secretly wrapped the gift. How did I wrap it? I wrapped it secretly. I barely touched the Christmas tree. How did I touch it? I touched it barely. Okay, so that is an adverb. Another part of speech is called an article. And an article is, there's only 3 of them. A, an, and the. That is the part of speech. An interjection is a word that you want emphasized in a sentence. So, wow, hey, ouch. And you'll see there's something that they share in common. What is that something?
Exclamation point.
Exactly. So an interjection shows emotion and intensity, and it has an exclamation point. Okay, there is something else. I don't know if you've seen this before, but I'm going to show it to you because this is how me and my generation learned about this part of speech. And it is Can you see my screen?
Yeah. No, it just says and the division. Okay, yeah, now I can.
Okay. All right.
As your body grows bigger, your mind gets smaller. It's great to learn, 'cause knowledge is power. Your schoolhouse rocket.
This was made in the 70s, by the way, so it's a little kind of crazy, but it'll help you remember.
You've been waiting for conjunction junction. Conjunction junction, what's your function? Hooking up words and phrases and clauses. Conjunction junction, how's that function? I got 3 favorite cards that get most of my job done. Conjunction junction, what's their function? I got and, but, and, or, they'll get you pretty far. And, that's an additive, like this and that. But, that's sort of the opposite, not this, but that. And then there's or, O-R, when you have a choice like this or that. And, but, and, or, get you pretty far. Conjunction junction, what's your function? Hooking up 2 boxcars, making them run right. Milk and honey, bread and butter, peas and rice. Hey, that's nice. Dirty but happy, digging and scratching, losing your shoe and a button or 2. He's poor but honest, sad but true. Conjunction junction, what's your function? Hooking up 2 cards to 1 when you say something like this. Choice, either now or later, or no choice. Neither now nor ever. Hey, that's clever. Eat this or that, grow thin or fat. Never mind, I wouldn't do that. I'm fat enough now. Conjunction junction, what's your function? Hooking up phrases and clauses that balance like out of the frying pan and into the fire. He cut loose the sandbags, but the balloon wouldn't go any higher. Let's go up to the mountains or down to the seas. You should always say thank you or at least say please. Conjunction junction, what's your function? Hooking up words and phrases and clauses in complex sentences like in the mornings when I'm usually wide awake, I love to take a walk through the gardens and down by the lake where I often see a duck and a drake. And I wonder as I walk by just what they'd say if they could speak. Although I know that's an absurd thought. Conjunction junction, what's your function? Hooking up cars and making them function. Conjunction junction, how's that function? I like tying up words and phrases and clauses. Conjunction junction, watch that function. I'm gonna get you there if you're very careful. Conjunction junction, what's your...
That's it. Fun. Okay. So the main conjunctions that we have, we can remember by remembering this, which is fanboys. So when someone says, what's a conjunction, you can say, oh yeah, fanboys. And here is what fanboys stands for. For, and, nor, but, or, yet, and so. And what this does is it joins two things. So here are some examples. Ducks and geese. I had neither rice nor beans. I'd like to go, but I had to eat first. Lila, or Cade will be there. I liked that ice cream, so I had another bowl. Does that make sense? It's combining one thing with another thing. I had neither rice, and then now they're going to say a second thing, beans. Lila and Cade. Lila or Cade. I liked that, so, and then they're going to say the next part about this detail. Does that make sense?
Mm-hmm.